All right. So last time we talked about breadth first search, BFS, as a way to traverse the graph. So today we're gonna look at another way to traverse a graph called depth first search. I think you've learned it from the previous course, but let's review it really quickly. The idea of depth first search is that you start at basically some vertex, okay? So this is where you are, and then you look around, and then you try to go to where you haven't been before, and you keep doing that until you cannot do that anymore. Okay. The idea is that you will mark each vertex if you have already been there or not, and then you look around, and then you try to make progress until you do that until you have nowhere to go. And on your way on to doing that, you keep track of the previous vertices that you have been you have already visited. You maintain something like a thread. I'll show you by example. And then when you're done, when you have nowhere to go, you go back, you backtrack. So you go back based on the thread that you keep. It's basically in your code, it's going to be a stack of the DFS function. Or if you write a DFS without using recursion, you have to maintain a stack on your own some way or another. So let's see by example. Okay, so if you have already visited some of the vertex, I'll mark it with this orange sign. Okay, so in the beginning, let's look at the case when the graph is undirected first. The directed version will be pretty much the same when you implement it. Okay, so we are here, so you're here, and you look around. So okay, when you start, you arrive at some vertex. Okay, and then you say, all right, I have visited this vertex, so I mark it. Okay, this is visited. Okay, and then you look around, you see two other vertices like 2 and 4, right? So in the algorithm, there's no specified ordering of vertices that you should visit. But for this example, let's say we pick the one with the smallest ID first. So basically, in the implementation, you just follow the order from the adjacency list. Now let's do it with the smaller number first. Okay, so you here, and then you see 2 and 4, right? You can go either way. So, but you pick the one with the smaller number. So I'll go to 2. Okay, when I go to 2, I keep something like a thread from 1 to 2. Okay, like that, and I say, okay, I'm at 2. Okay, and then let me throw away this guy. Let's try to follow my pointer instead. I look around at 2, right? And then I see 3, right? There's no other choice, so I move to 3. And I mark, okay, this is a new guy that I made. Okay, now at 3, I have 2 choices, either go to 5 or 4, right? So let's pick the smaller one, and I go to 4. And then I mark 4 as visited. Okay, if you follow the thread, the pink thread that I have, it's gonna look like this: 1, 2, 3, 4 on this line. Okay, it will be important later. Okay, so now at 4, I look around, I see 1 and 12, right? 1 has a smaller number, but I have already been there, so I just ignore it. Okay, I'm not gonna go there. I'm not gonna go there. So I'll go to 12. Okay, with this pink line. Okay, then at 12, I have nowhere to go, right? I'm done. I'm kind of done. Okay, but is it true that I visit all the graph? No, right? So I need to go back. The way I go back is that I will follow back the thread that I have put on, right? So this is like in some old Hansel and Gretel story, right? So you have a house, okay, and you visit somewhere, and then you keep on the breadcrumb so that you can go back, right? So this is the same thing. Okay, so when I'm done at 12, I need to go back. This is backtracking. Okay, backtracking. I'll backtrack using the blue the pink thread that I already put there. Okay. So in your implementation, you do that automatically because you use recursion. So you backtrack once, but here at 4 you have nowhere to go, right? You can go to 1. You already went to 12, so you backtrack again to 3. Now at 3, okay. So before we doing that, let me give you another sign. Okay, so I would draw a black line like this. This is a tree edge. I keep this black line as a when I find a vertex, I keep the black line. This black edges become would tell me the depth first search tree. So this is like I have found 2 from 1. I have found 3 from 2. So I keep this black edges. Okay. Now I'm backtracking to 3. Okay. Then I am gonna go where I'm gonna go next. 4 is already visited. 2 is already visited. Now I'm gonna go to 5. Okay. So I put a bit. This is new vertex, right? So I find new vertex, and I keep the pink line over there. And I also add this. This is the tree edge that I have. Okay. Now after I backtrack, right? I backtrack to 3, right? And I 4, 5, 5. So I add 5 there. Okay. And then 5 will go to 6, right? And 6 will go to 14. No, let's do that. 14. I found it. And then 14 will go to, from 14, I go to 15. Here's another interesting point. 15, you have nowhere to go, right? 6 already been visited, 4 has already been visited. So you backtrack, okay? Before I backtrack, let me mark the tree edge that I have found. So the black edge is like the same as the pink edge, okay? But the pink edge is like is dynamic, so I remove it from time to time, right? So 5, 6, 14, 15. Now I'm gonna backtrack. So I'm gonna backtrack from 15 to 14, but there's nowhere to go, right? So I backtrack to 6. Again, nowhere to go. I backtrack to 5, and then at 5 I can go to 7, right? So now let me clear my stack and let me remove the pink edge over there. Now I'm at 5, so I would go to 7. Okay, so 7 is visited, and then from 7 I would go to 8, right? And 8 to 9. Okay, with corresponding black edge. So this is tree edge. Again, at 9, I'm done, kind of done. I have nowhere to go. So at this point, my stack would look like this: 5, 7, 8, 9, and then I have nowhere to go, right? So I backtrack from 9 to 8, nowhere to go. 8 to 7, okay. Now, when I'm at 7, I have another vertex that I can go, right? 10, okay? So let me clear up my stack here. Then I go to 10, okay? Let's see my pink line over there. And then I mark 10 as visited. And then from 10 look at 3 visited. So 10 would go to 11 and 13, right? With corresponding stack, okay? When I'm at 13, my stack would look like 10, 11, 13, okay? Now I'm gonna backtrack, okay? So 13, nothing to do. 11, nothing to do. 10, done. 7, done. 5, done. So it's gonna be done all the way around back to 1, right? And then you're done, okay? So you're gonna backtrack. So let me write the black edges one last time. Okay, I'm gonna backtrack. So I'm gonna backtrack that, and I'm back to 1. Okay, so this is the end. I visit all the vertices. Okay, let me show you the tree again. So the deficit tree would look like this. So this is the tree edge. This is the edge that let me find all the vertices, right? Okay. So deficit tree has a really nice structure, but we're not gonna cover it that much in this course. But the way it is really useful because you can implement deficit pretty easily, okay, using recursion and if you wanna work on reachability. So if you want to check if one vertex, is there apart from one vertex to another SNT, you can use breadth first search, sure. But if you use depth first search, it's usually easier to write. And, when you are in an exam or something, it's easier and the code will be like much, much shorter, okay? All right. So let me show you the animation. You can go watch the animation on the Visual on AlgoLab website. So so this is the start. So let me show you how it runs. I increase the speed. So this is like you find a new vertex and so on, right? Like that. And then when you have nothing to do, backtrack. Okay, the yellow. Okay, and then you have find another one. Okay, and then you backtrack. Then go ahead and so on. And then backtrack. Okay, backtrack. Okay, so this is how thing works. You can look at the animation from this website. It's really nice. Okay, all right. Okay, so now let's write the code. Okay, so let me use C Lion so that you might want to try it. Okay, so this is the old code that reads the graph and keep everything inside the adjacency list. Okay, this is the code that I took from the wiki. Okay, so now let's try to write depth first search. So basically the first thing that we need to do is to have a bool, okay, to keep the visited state, right? And you need to initialize it. So initialize init visited. Okay. Okay, so so you see it's trying to autocomplete for me. Okay, now I initialize the whole thing. All right. Okay, it doesn't like my style of having the curly braces on the next line, so let's do that. Let's follow it. So now we want to do depth first search. Okay, so y DFS U. Okay, so when you arrive at U, yeah, I say I have visited the whole thing, right? So then I look at vertex. I have, so at U, right, the adjacency list is ADJ U, right? So I iterate over everything in the adjacency list of U. So you can use this new kind of for loop to iterate over the adjacency list, right? It's a vector, so you can do for V inside this guy. Okay, and I need to check so that my new vertex is V, right? So I need to check if I already visited V or not. If I haven't visited V, then I call DFS V, and this is it. This is the first search. Okay, so that's the whole code of depth search, which is like really short, right? So if you want to write a code that count the number of connected components, so you can just call depth search, right? So let's try to do it. Okay, So I have a counter, then I for in u less than n, okay? And if not visited u, then I call the first search u. Okay, this is a loop that try to call default search at every vertex that you haven't been found, right? And then so I add increase the counter, and then you just see our counter. Okay, so this is the code that basically count the number of connected components that we can try to run it. Okay, so let's get some test data. Okay, so let's run it. Okay, so that's from the example. Okay, let's run it again. So in this case, it should be 3 components. So basically, this is it. Okay. So the first search, if you want to just to check, if there's a path between 2 vertices in the graph, the first search is basically your best friend, right? You can just, it's really short. It's easy, really easy to write. Okay. So this is the another graph traversal technique that we haven't been mentioned from last time. Okay, see you in the next video.